potassium aluminum sulfate, commonly known as potassium alum, is what we're going to grow crystals out of. And the maximum concentration that you can have in water at around room temperature, about 22 degrees, is 0.15 grams per milliliter for potassium alum. You receive about 50 grams of potassium alum in this tube, and what we want to do is weigh its mass and then do a calculation to figure out how much water we have to mix it with in order to make a saturated solution. Everyone has in their kit either a 500 or a 1,000 milliliter beaker, and either one of those can be used for this. You want to take the beaker and put it on the scale, turn the scale on. If it doesn't read 0, tear it, and then pour all the potassium alum into the beaker. Looks like I have 54.37 grams. So that goes there in this calculation, and I want to solve for the volume, x. So I calculate it's 362 milliliters that we have to dissolve that in order to make a saturated solution. So we want to prepare the solution of potassium alum using room temperature water, because we'd like to prepare a saturated solution and we don't want the temperature of the water to have to change over time to the temperature of the room. I have to put 362 milliliters total volume in here, so I'm going to add this water slowly until I'm close to 300 milliliters. Then I'm going to use a dropper to carefully top off and get up to 300 milliliters. Then I'm going to measure the last 62 milliliters in the 100 ml graduated cylinder. And before I pour that in, I'll carefully adjust it using a dropper. Now I'm going to stir this for 5 minutes. 5 minutes have passed and I've been stirring, and I can still see that there are crystals that are not dissolved. So I'm going to put 1 full dropper full of water in there, and I'm going to stir for another couple of minutes. After a couple more minutes of stirring, the solid still hasn't dissolved completely, so I'll put 1 more dropper full of water and I'll stir for a few minutes. Now it still hasn't all dissolved, and at this point, if it hasn't dissolved, we would go on the idea that it's possible that what's not dissolving is an impurity, that it's not the potassium aluminum sulfate, because if we calculated correctly, it all should have dissolved. So next we're going to filter the solution to remove that undissolved solid, whatever it may be. And the way that we do that is using a 1-quart container to collect the solution in. We use this as a funnel, and we use a coffee filter to do the filtration. All right, it's taken several minutes for the solution to completely drain, but now I've collected a saturated solution of potassium aluminum sulfate here, and I should label it as that. Next, I'm going to take about 100 milliliters of the saturated potassium alum solution, and I'm going to put it in a clean mixing container. I'm going to cover it with the cheesecloth, and I'm going to put a rubber band around the top like this. The cheesecloth prevents dust from getting in to keep the solution pure, but it allows liquid water to evaporate off and allow the solution to become supersaturated and start to form crystals. You should leave this solution in some place that has a moderate temperature and a temperature that doesn't fluctuate a lot. Don't leave it near a radiator, don't leave it near a window, leave it towards the center of your house. The center of your apartment is a good place, and be careful to put it in a place where it won't get knocked over. After a week or more, you should expect that some evaporation has occurred here, and you may have some seed crystals collected. So you can view from the side to see if there are crystals, and if there are, take the cheesecloth off. I can definitely see that there are crystals in the bottom there, so I want to filter this to collect those crystals and use them as a seed to grow a larger crystal. So we set up a filtration apparatus similar to how we did before. And before you try to filter, you should stir around here because the seed crystals very well likely are stuck to the bottom. Okay. All right, so the solution is drained through here, so I want to get a look at the crystals that I have. So you can split the filter open, lay it out, and look through what you have. Many of these are what you would call polycrystals. If you look at them closely, you'll see they're separate crystals that are stuck together. They're emanating out in single directions. We'd like to capture the biggest single crystal that we can find in this batch. Okay. After you pick out a crystal that you think is the biggest single crystal you can find, make a loop in the dental floss that was provided in your kit and try to capture that crystal in the loop. Just like that. Now you can take a pair of scissors and cut off the excess dental floss. And this crystal that I've captured, we're going to use as a seed to grow a larger crystal. So what we want to do is take a clean 100 ml container and fill it with the saturated potassium alum solution, about 100 milliliters. Then take the cheesecloth and put a small hole in it using a pencil. Next, weave the dental floss through that hole. Then dangle the crystal down into the solution. Put the cheesecloth on top. Hold it all together with a rubber band and push or pull the dental floss to adjust the height so that the seed crystal is about in the middle of the solution or a little bit lower. Leave this solution in the same place that you left your solution to grow the seed crystal. We'd like a moderate temperature, and we'd like the temperature to not fluctuate much if possible. So now my seed crystal has been hanging for 2 weeks, so I'm going to examine it to see how much it's grown. And you can see it's grown substantially as the liquid level here has gone down. Put it back in that solution, restore this to 100 milliliters, and let it continue to grow.